So in the first example here, we're looking at a driver who's going from 24 meters per second to 15 meters per second in 12 seconds, and we want to know what the car's acceleration is. And an important note, remember that a negative value indicates a slowing down or a deceleration. So let's have a look. Using our definition of acceleration, we know that acceleration is change in velocity over time, or the final velocity minus the initial velocity over time. Now in this situation, the car starts off at 24 meters per second and slows to 15 meters per second. So the initial velocity is 24 and the final velocity is 15. So you should have 15 minus 24 over the time in which that took, which is 12. Now on the top you'll notice that we have 15 minus 24. Is it an issue that we're going to get a negative number? No. Hopefully you guys didn't try and just rearrange it so it said 24 minus 15 so you had a positive. We actually need that negative value there because that's going to indicate what? Deceleration. So 15 minus 24 divided by 12 gives us negative 0.75 meters per second squared. Alright, you could have just written meters / second to the power of 2, either one's fine. And then I would just make a little comment, that is decelerating at a rate of 0.75 meters per second squared. And then that makes sense of what that negative sign means. Alright, next one. A parachute on a racing dragster opens and changes the speed of the car from 85 meters per second to 45 meters per second in a period of 4.5 seconds. What's the acceleration? So we're using that same formula again. Acceleration is equal to final velocity minus initial velocity over time. In this situation, it went from 85 to 45. So its final velocity, again, is the 45. Minus the initial velocity, which is 85, over the time taken, which is 4.5 seconds. You can see again that since we've got a smaller number in front, we're going to get a negative value. Is that an issue? No, it just indicates a deceleration. So you should have got negative 8.89 meters per second squared. So that is decelerating at a rate of 8.89 meters per second squared. Is that what people got? Cool. Next one, the table below includes data for a ball rolling down a hill. Fill in the missing data values in the table and determine the acceleration of the rolling ball. So this table just requires you to use a pattern to fill in the missing boxes. You can see that the speed after every 2 seconds is increasing by 3 kilometers per hour. So these went up in 2 second intervals. So this was 2, 4, 6, 8, 10. And then the speed 0, 3, 6, 9, 12, 15. Alright, so you should have been able to see the pattern there. And if we want to determine the acceleration, we have to remember acceleration is defined as change in velocity over time. So since this is in seconds and this is in kilometers per hour, can you see the issue with that? Right, because the units are different, you need to keep the units consistent. So I would be converting maybe some of these to meters per second. Alright, so to convert 3 kilometers per hour into meters per second, do we know how to do that? It's on the board. We multiply by 3.6. Alright, so this would be equal to 3 times 3.6 is 10.8. So we divide by 3.6. So 3 divided by 3.6 is equal to 0.833 meters per second. Now, do I only have to do that conversion for one of the times? One of the speeds? Alright, why is that? Because I can use 0 as my other one. Yeah, I can use this one because 0 kilometers per hour is the same as 0 meters per second. Alright, so now if I want to do acceleration, we know it's final minus initial over time, which is equal to my final velocity will be 0, my initial velocity will be 0.88. This is my initial, this is my final. So it's going to be 0.833 minus 0 over, what time interval did that happen? 2 seconds, which is equal to 0.417 meters per second squared. If you didn't do the conversion to meters per second for this velocity, your data would have given you a incorrect value. Would mean nothing. Alright, so you needed to do that because this was in seconds. If they'd given us this time in hours and that speed was in kilometers per hour, then we could have just left it as it was and we could have worked out the acceleration that way. Alright. Were people okay with that one? Alright, so you can fix that one up if you didn't get it right. Next, a car traveling at a speed of 30 meters per second encounters an emergency and comes to a complete stop. How much time will it take for the car to stop if it decelerates at -4 meters per second squared? So now you can see that we have to use one of our other formulae. It's just a rearrangement of the acceleration equals change in velocity over time. So this second one that we use, so you should have used t equals v minus u over a. Is that what people did? So t equals v minus u over a. It was traveling at a speed of 30 meters per second but comes to a complete stop. So what's its final velocity? 0. So you should have got 0 minus the initial, which was 30, over our acceleration. Deceleration was -4. And this is important. See how this was -30 and then we've got -4 at the bottom. If you didn't have the -4 for the deceleration, you would have got a negative value. Can we have a negative time? There's no such thing. So therefore that works out. So we go 30 divided by 4, which is equal to 7.5 seconds. All good? Alright, number 5. A cart's rolling down an incline for 5 seconds, has an acceleration of 4 meters per second squared. If the cart has a beginning speed of 2 meters per second, what's its final speed? So again, we're using a different formula. We're using the last one that we rearranged. V equals U plus AT. So V is equal to U plus AT. What's my initial speed? 2 plus the acceleration of 4, and the time is 5. So we go 4 times 5. Now you don't need a calculator for that. 4 times 5 is 20, plus 2 is 22 meters per second. All good? Alright, continuing on. So a helicopter speed increases from 25 meters per second to 60 meters per second in 5 seconds. what is the acceleration of this helicopter? Again, same type of thing. Acceleration equals v minus u over t. My final velocity, since it increases from this to this, is 60, minus the initial velocity, which is 25, over the time taken is 5 seconds. Always make sure you compare the units. This is in meters per second, that's in seconds, therefore I can do this. So 60 minus 25, it's 35, divided by 5 gives me 7. And what are my units going to be? Meters per second squared, or meters per second. I don't mind how you show it, I just show it with a -2. Alright, last one I'll go through, and then you can finish off the sheet yourself. As she climbs a hill, a cyclist slows from 40 kilometers per hour to 10 kilometers per hour in 10 seconds. What's her deceleration? Alright, what's the issue with this one? Pardon? The units. Since this is in seconds, that's no good for us. Since this is in kilometers per hour, and this is in kilometers per hour, let's convert this one to... Would you try and convert these two to meters per second, or would you just put that into hours? Does it make a difference? No, you can do it either way. What did you guys do? You changed these into meters per second. Alright, yeah, you could do it like that. Or we could put that into hours. Do we know how to convert seconds to hours? 1 second is a fraction of an hour. Divide by 3,600, because it's 3,600 seconds in an hour. Alright, so I'll do it that way. So t is equal to 10 seconds, which is equal to 10 over 3,600 hours, which is equal to 2.7 times 10 to the power of -3 hours. What does that mean? It just means 0.0027 hours. So therefore, the acceleration is equal to v minus u over t. It goes from 40 to 10. So that means its final is 10 minus 40 over, use this converted time, this is 0.0027, which is equal to -30 divided by 0.0027 minus 11,111. Now, since I've put it in these units, it's going to be... Oh, I just realised I didn't have to do what I just did. I could have just left it in seconds, and the deceleration would have been kilometers per hour per second. You could have used those units. So now my units are going to be kilometers per hour, which is a bit of a weird unit. Alright, so maybe discard what I did on that one. You could have just gone divided by 10. Alright, so this one here, you could have left this as 10. You could have left this as 10. And you're going to get -30 over 10, which is -3 kilometers per hour per second. You could have done it like that. Alright, and that's it.